This video is about the constant omega. Omega doesn't exist. The constant omega is defined as something whose non-terminal punctal cannot be, omega is a constant, cannot be described in any shorter than its non-terminal punctal, which is basically nonsense. I'm going to prove that this omega doesn't exist by pointing out that, and we're going to use the binary representation because it's easy, it's the simplest. If we bifurcate our representation, intended representation for omega, we have a choice between the first digit being 0 or 1. An infinite number of irrational numbers with non-terminal binary representation. An infinite number are in each camp. You know, one side starts with 0, the other side starts with 1. There's an infinite number that shares each. If we take the next step, of course, for 0, there's the choice for the next step is either 0 or 1, and also for 1, the next step is a choice between either 0 or 1. And so of each of the infinite sets, we cut both infinite sets in half, and now we have 4 infinite sets that share each of the 4 possible sequences, and so on. Each next step divides the infinite sets in each of the infinite sets into 2, and they remain infinite. And so we do this forever, world without end, and we never run out of, we never run to the end of a sequence where an infinite number of irrational numbers share the same representation, punctal representation, in this case a binary representation, but any punctal representation. The choice of radix doesn't matter. If the choice of radix mattered, then this proof would not be valid. But it doesn't really matter what radix we choose. We'd be dividing the infinite sets by some finite number, and we could do this over and over again endlessly, and we would never have anything left over. There's supposed to be a leftover decimal or binary or some punctal once all the other irrational numbers were sorted, and that just doesn't happen. So no matter what we do, we can always have a shorter representation for any of the numbers in the infinite sets that share common punctal sequences. QED.